Hey guys, my name is Jesseline and I just want to talk about Pythagorean Theorem. So first of all, I just kind of want to go over the parts of a right triangle. So when you hear me say these words, you'll know exactly where they come from. So we have a right triangle. So here's my right angle. A right angle means 90 degrees, right triangle. And so we have, this is a leg, this is a leg. The two legs make up the right angle. And then across from the right angle, always opposite of the right angle, is what you call the hypotenuse. Okay, it's always opposite of the right angle. Okay, it's the hypotenuse. And so knowing that, so a lot of people are like, oh, I know Pythagorean Theorem, and they just shout out the formula. Well, where does that come from? So what's cool to see is if I have a triangle, well, that one's gonna be too big. I won't be able to do all my drawings. So if I have a triangle, and that one's kind of too small. Ugh. There we go. Okay, I have a right triangle, and let's say I make a square off the sides of the triangle. So I'm gonna get my other pen here. So let's say I use this side right here to make a square. Okay. And then I do the same here. I use this side right here to make a square. Sorry if my squares aren't really square, but I'm trying. And then over here, I make this side right here and make a square off of that. Okay, so what you do if you were to do this puzzle, you would notice that this square right here added to this square right here would equal this square right here, the area of it. So the area of this blue square plus the area of the purple square equals the area of the black square. And if I were to just name these sides, let's say I name that A and I name that B and I name that side C, just like you do in the Pythagorean theorem, you have A squared plus B squared equals C squared. Well, the area of a square, if the sides are B, we know area of a square is just side times side. Well, B times B is just B squared. So the area of this square would be B squared. And then the area of this side, this square with the sides of A is A times A, which is just A squared. So that's A squared. And then, oh, I shouldn't write on top of the thing, on top of other things. And then this one C is C times C, which is C squared. So the area of that one is C squared. And so that is where Pythagorean theorem comes, because the area of the purple square, represented by A squared, and the area of the blue square added together equal the area of that black square, the bigger square. So that's where A squared plus B squared equals C squared comes from. So, for example, using A squared plus B squared plus C squared, A squared plus B squared equals C squared. So using that, so we have a triangle, and it's a right triangle, and we're given that 3 and 4, and we want to find C. So we just simply substitute these in for the formula. Actually, the legs are interchangeable. That's what you call the commutative property, when you can switch the order. So it actually doesn't matter which one's A and which one's B. This one's usually A when teachers, and then B, but it doesn't matter. You just, it's the square of the sums of the legs, the two sides that make up the right angle. Okay, so the square of the sums of the legs equals the square of the hypotenuse. So now we're just going to continue to solve that. 3 squared is 9, 4 squared 16, and we still have C squared over here. 9 plus 16 is 25 equals c squared. Now to solve just for c, this is like solving an equation. Since it's c squared, we have to take the square root. Okay? So c equals the square root 25 is 5. And if you don't know how to solve equations, go and watch that video. It'll be helpful. Anytime you have a c squared and just want 1, you always take the square root of it. So that's how you use Pythagorean Theorem to find a side. We can do another. So we have 5a and 13. So in this case, we're looking for a leg, but we're still going to just substitute everything in to a squared plus b squared equals c squared. So we don't know a, we do know b. Remember, I could have put 5 in for a, but it doesn't matter because the legs are interchangeable. And then c squared, 13 squared. So I'm going to continue to solve it just like a normal equation. 5 squared is 25, 13 squared is 169. Subtract 25 from both sides. A squared equals 144. Remember, anytime you have a square, to get just 1, you take the square root of it. And so a is equal to 12. Remember, what you do to one side, you have to do the other. So just simple, and you substitute it in and then solve the equation. Let's talk about a few things that might come up when talking about Pythagorean Theorem. The first one is altitude. A segment, so the altitude of a triangle is a segment from a vertex of the triangle perpendicular to the opposite side in a right, to the opposite side. So in a normal triangle, or not a normal, but in a non-right triangle, it's this, the segment that goes perpendicular to the opposite side from the opposite angle. That would be the altitude, okay? So, but in a right triangle, if you notice, in a right triangle, if you notice the two legs are altitudes of the triangle. So right here is an altitude and right here is an altitude. And then, okay, so for example, given a triangle, given that this is 10 and that this is 10 and this is 10, and I say I want you to find the height, we can use Pythagorean Theorem for that. Because if you look here, this right here forms a right triangle because we know the altitude is perpendicular. Perpendicular means that it forms a right angle. So we know it's a right triangle. So we can look for h, but the thing is right here, how do we know this side? Well, if it's perpendicular and it bisects that angle, that means this side and this side are congruent. And if the whole thing is 10, and if both sides are congruent, we just divide it by 2. So we draw our half of a triangle. We know this side's 10, we know this side's 5, and we're looking for the h, the height. And then this is our right angle, right? Our right angle, I'm just redrawing the triangle. And then we use a squared plus b squared equals c squared to solve it. So a is one of the legs, so it doesn't matter. I can use h squared for one of the legs, and then the other leg I can plug in 5 squared. And then c squared is always the hypotenuse, so 10 squared. And then we solve it. H squared plus 25 equals 100. Minus 25 from both sides. H squared equals 75. And then take the square root, h is equal to the square root of 75. Now we can simplify that radical. Again, this is not a lesson on simplifying radicals. You can go watch a video on that. There will be one if there is not one already. So 75, we're going to simplify it. So I'm looking for a factor of 75 that is a perfect square, and I know 25 is. So square root of 25 is 5, and then 3 is left in the radical. So 5 square root of 3 is my answer for the height of that triangle. We can also talk about the converse of Pythagorean theorem. Remember, the Pythagorean theorem says if it is a right triangle, then a squared plus b squared equals c squared. So the converse of that, remember converse is when you switch it, would be if a squared plus b squared equals c squared, then it is a right triangle. So what you can do is you can be given lengths, and it will say, is this a right triangle? So you just test it out. A squared plus b squared equals c squared. So that's 4 squared plus 6 squared equals 8 squared. So I'm going to solve it. 16 plus 36 equals 64. And then 16 plus 36 is 52. It equals 64. That is not true. So this is not a right triangle. But we can decide what type of triangle it is just by looking at this. So if it doesn't equal, so like that doesn't equal, so it's not a right triangle. So it's not a right triangle. But is it acute or is it obtuse? So if the sum of them, so if a squared, if the sum of the legs is greater than the hypotenuse squared, then it is an acute triangle. If the sum is less than the hypotenuse squared, it is an obtuse triangle. So in this case, it's 52 is less than 64. So the sum is less than the hypotenuse. So that means that this would be obtuse. It'd be an obtuse triangle since the sum is less than the hypotenuse squared. It'd be an obtuse triangle. And there you go. There's Pythagorean theorem. Thank you for watching.